Hello and welcome back. We'll start section 1.2 in this video, which is on angle relationships and similar triangles. So when we say angle relationships, what we're referring to is when lines will cross and then there's going to be a relationship between the angles that are formed in here. So if this angle on the left is x, whenever we have two straight lines, we know that since this is a straight line, the angle up top here and this angle x are going to have to add up to 180 because this is the angle that a straight line makes. These are supplementary angles. So I know that this angle up here is going to be 180 minus x. So that if I add those two together, I'll get 180. But then if we follow this straight line, we know that 180 minus x and this angle over here are also going to have to add up to 180. So 180 minus x plus x happen to add up to 180. So we see that the angle on the left-hand side and the angle on the right-hand side are the same. And the angle on the bottom, by the same logic, is also going to have to be a supplementary angle to both of these. So this is also going to be the same. So when we look at this, we see that we have a pair of angles that are the same. And we also have another pair of angles that are the same. We'll use multiple marks to say when angles are the same. So the angles on the left and the right are the same because they have one mark, and the angles on the top and the bottom are the same because they have two marks. But we can go even further than this. So if first, I do want to emphasize the fact that the top and the bottom lines are parallel. If they aren't parallel, nothing that I'm about to say would be true. So this is an important assumption. So we know from before that say when these two lines cross, we know that the opposite angles are going to be the same. Okay. And since this line is going to cross this line at the same angle that this line is going to cross this line, this might be a bit messy, so let me erase some of these lines. The angles down here are all going to be the same as the angles up here. So if I were to label these 1, 2, 3, 4, 5, 6, 7, and 8, we'll see that 1 and 4 are the same angle because they're opposite one another. 5 and 6 are the same angle because they're opposite one another. But also, the angle at 1 is going to be equal to the angle at 4, which is going to be equal to the angle at 5, which is equal to the angle at 8. All of these are the same. Again, these are just exact copies of one another. This is a straight line. These are straight lines that are parallel. All of these things are the same angle. So when we have drawings like this, whenever we have parallel lines, there's a lot that we can say here. And then likewise, 2 is going to be equal to 3, is going to be equal to 6, is going to be equal to 7. All of these angles are also going to be the same. So let's do an example where, let's say that I want to know what the angles are in these places. So here I have 2x degree angle, and here I have an x minus 30 degree angle. So the question is, what are those angles? Well, we can fill in our drawing here because these guys are opposite. This angle is also going to be x minus 30. And then because these angles are opposite, this is also going to be 2x. And assuming that these lines are parallel, which is just an assumption that we'll have to make here, these four angles and these four angles are going to be the same as well. So this is going to be 2x, this is going to be 2x, this is going to be x minus 30, and this is going to be x minus 30. So then from here, we've filled in all the information we can. Now we'll have to use a little bit more. So for instance, these two angles here, maybe I can do this in a different color, these two angles there form supplementary angles. This is a straight line, and those two angles together form that straight line. So we know that 2x plus x minus 30 is going to add up to the angle of a straight line, which is 180. So let's add these together. 2x and x is going to be 3x. Minus 30 is 180. Move the 30 to the other side. We're going to get 210. So x is going to be 70. So plugging in 70 into 2x gives us, okay, this angle is 140. And then the x minus 30 in the middle there, 70 minus 30, well, that's a 40-degree angle. So we found both of our angles. So it's 140 and 40. And we can fill in the rest as well. So this is a 40-degree angle, this is a 40-degree angle, this is a 40-degree angle, and so on and so forth. The other ones will all be 140. So there's a lot of information that we can deduce from not very much. This is the power of angles. So the sum of the angles inside of a triangle is going to be 180 degrees. This is something that I feel a lot of people are familiar with, but maybe you don't know where exactly this comes from. So I do want to go through the steps and show you everything that we've just talked about is enough to prove this fact. So let's call these angles A, B, and C. And what I'm going to do is I'm going to extend these lines further. So we're just going to extend these lines as if we have a bunch of straight lines that are intersecting one another. And I'm going to take a parallel copy of this line here, and I'm going to put it so that it passes right through this one. So these guys are going to be parallel. And now I'll show you that A plus B plus C is going to add up to 180. So again, up here I have a straight line. So angles 1, 2, and 3 should form a straight line, so those should add up to 180. A here is the opposite angle for this guy. So this is also an angle that is A degrees. B here, so now I want to focus on, maybe I can do this in a different color, so let's do this in red. If I have this line here, and these two lines, B is going to be the same angle as this angle up there. Again, this comes directly from this shape. We have two parallel lines, we have an angle coming down, so 6 here and 2 are going to be the same. So let's, I'll fill in the B again. And then lastly, we're going to do the same thing with the other line coming across. So we have our two parallel lines and our line coming down. So guess what? C here, this angle, is the same as this angle right there. Again, we have two parallel lines, this line coming down, this angle and this angle are going to be the same. So let's erase those red lines. So I know that this angle is C, this angle is A, this angle is B, and they form a straight angle. So C plus A plus B should add up to 180, which happens to be the three angles inside of the triangle. So now you know why the angles on the inside of a triangle add up to 180. This is just one way to show this. Cool. So once we know that, we can use this information to say find some angles in triangles. So for instance here we could try to find this angle X. So they give us a 60-degree angle, but that's it. Well, not quite. We've got to remember that whenever we see the pointy angle sign, this is a right angle, so this is 90 degrees. So we know that X plus 60 plus 90 has to add up to 180. And subtracting 60 from both sides, subtracting 90 from both sides gives us X is equal to 30. So, and this happens to be a special kind of triangle where all of the angles are quite nice. This is called a 30, 60, 90 triangle. And these will show up quite often in the future. Calculations with them are quite nice. So again, angles on a triangle add up to 180. It's a nice fact. So there are various types of triangles, and we can distinguish between the types of triangles either by looking at the angles inside of the triangle or the sides of the triangle. So the types of triangles that we'll look at are acute triangles, right triangles, obtuse triangles, but also equilateral, isosceles, and scalene triangles. So in terms of angles, it could be the case that all the angles are acute. Acute means less than 90 degrees. So for instance, it could be that all the angles are 60. 60 plus 60 plus 60 will add up to 180. They don't all have to be the same. They could all be different. But as long as all the angles are acute, we have an acute triangle. A right triangle is any triangle that has one angle that is a right angle. It is impossible for a triangle to have two right angles because both those angles are 90 degrees, and that adds up to 180. So what can the third angle be? 0? Well, that's not even an angle. So there can only be one right angle in a triangle. And the same thing for an obtuse triangle. So we could have one angle be 140, and the other two would be something like 20, for instance. But you can only have one you can only have one obtuse angle in a triangle, because if you have more than one obtuse angle, it's going to add up to more than 180 degrees, and that can't happen. So we can identify triangles based on, okay, the angles, are they all acute? Is there a right angle, or is there an obtuse angle? Lastly, we can look at the side lengths. So equilateral, at the beginning of this is a hint. This is when all the sides of the triangle have the same length. So if all the sides of the triangle are the same length, this is called an equilateral triangle. And furthermore, if all the sides are the same length, that means that all of the angles are going to be equal as well. So there's only one kind of equilateral triangle. All of the side lengths are the same, and all of the angles are the same. For an isosceles triangle, that's when two sides are equal, and the third side will be different. So again, I'll use marks to say when side lengths or angles are equal. So for instance, over here, each side has one mark, so they're all equal. Here, these two sides have one mark, and this one has two marks. So an isosceles. This last one is a scalene, when this would be one side, two sides, three sides. They're all different from one another, so I'll use different numbers of marks. So acute, right, obtuse, equilateral, isosceles, and scalene. Just some terminology to help us. I think I will continue with the next bit in the next video.